It's exciting to have all these folks online and here to present. I'm going to be very brief so that we can get through everybody's conversations. But this is a stand up on ETL or ELT work in OpenMRS, and really is generated from our interest in getting a shared or common solution or approach that instead of everybody in isolation or in siloed efforts trying to solve this problem around the world, trying to get an approach that is forward thinking and scalable that we as a community can all start putting our effort in. And by hearing what everybody's doing and all the exciting work going on and working together, we hope that we can start an effort that everybody can have some benefit from. So I'll stop there. We're gonna hear from a bunch of people, and I'll stop sharing, and we'll, I think, start with Vecna Cares.
This is Paul from Vecna Cares. We had two projects that started leading us to around this initiative around creating a data warehouse. And so the team did a lot of research around a lot of different potential pathways. Bought in some outside help, and I think they've been working on it for probably over a year at this point, with some of the work still upcoming. But I'm gonna hand it over to Mukesh, who's gonna provide some more details.
Yeah. So thanks, Paul. Let me share the screen first. Let me know once you guys see the screen.
Yeah, that's good, Mukesh.
Yep. Okay. Yeah. We have a different. I'm just giving us some overview on how we going to data warehouse and why we use this ETL tool and some concepts. We already mentioned that we are working on the two projects for the data warehouse, where we one of the project we have to fetch the data from the multiple data source to the data warehouse, and we have to integrate the data warehouse to the some visualization tool. So we are working on that, and yeah, that is a summary. And we use in core implementation of data warehouse star schema design, dimensions, facts, ETL. So star schema design, this is our core data warehouse, which is implemented on this pattern. So here is the dimension. So we have taken such as concept as a dimension and storing this value in the fact tables. So fact is the real measure. So measurement value, numeric values on outputs. So these are the facts. And ETL, we use a tool for the ETL process, which extract, transform, and load the data. So this is our slide, which is giving an overview of how we implemented the DHIS and how we integrated the data warehouse with the different OpenMRS source, and also we are working on the integrated the DHIS tool with the data warehouse. So here our main problem concern is that there are too much OpenMRS source in the entire globe, and some have the prior version, some are running on the latest version. So there are also version mismatching on their different sources, and we are extracting from all these sources to our staging area. So this is not a data warehouse, this is a staging area which is intermediate between the data warehouse and OpenMRS, from where we can transform the data and load into our data warehouse. According to business cases, we are implemented the data warehouse, and after that we are integrating a business tool on this, like SAS, DHIS2, Power BI, but previously we are using the SAS try to integrate, but now we are starting to integrate the DHIS2. this is the overview of the star schema. So these are the dimensions, and just like in our screenshot, these are the company, products, and time. I mean, these are the dimensions which are not related to our current implementation. These are for the example. And these are the, and in between that, I think this is a fact. So where we are storing all the measurement of the dimension in the fact table. So again, these are dimension. So this is giving the brief information about what is dimension. So dimension are the character. This is dimension table store the description of the characteristic of the business. A dimension is usually descriptive information that qualifies a fact. So whatever the values we are storing in fact, because fact is a core part, and we are taking a business decision from the fact, and doing analysis on the fact tables for the data visualization and business description. So dimensions are the we can say that attributes of the that facts. So for example, we have a company here. So company have the some id primary key and the company name and some address. So and we have the dimension time when company is started, and how much customer is there. So all these dimensions integrate in the fact, which is giving a over complete information uh, about the data. So this is here dimension primary key is here, this is a measurement data, and foreign key customer, foreign key of the company, foreign key of the customer. Yeah. So moving forward, so this is slowly changing the dimensions. So these are the our concept which are using SD1. Overwrite old data with the new data does not track the entity. So if there is some old data in the dimension and that is some previous data is updated, then that should be reflect on the new changes. Track history of adding new rows for the updated data. So these are the common requirements. And modified table structure by the adding new column to track. Yeah. So earlier I told that we have the different sources, and maybe some sources have the different column, different number of the columns. So we have to make our database so much flexible to add the column also, and track history using the history table. So column mean dimensions column. Yeah. This is fact, which is a real observation data. So fact table contain a data column for the numeric measurement of the business. So it also include a set of column that are concatenated or the composite key. So these are fact is measurement data, right? And these are the key constants we are looking for implement the our ETL tool. So rest data between the tasks. So this rest data between tasks, if we run a workflow, and a workflow is associated with the different tasks. So the different tasks, all the task data will be saved in the data warehouse, and that not be a duplicate. So not, this is for this data between tasks. Load data incrementally. So load data incrementally, our concept is here to load the data by incremental order. I mean, when the next scheduler, or we can say that scheduler DAG and uh, transform and load thread, when the next scheduler will run, then that will take the date of that day and increment the data, and fetch the data from the different source on load in the data warehouse. Enforce idempotency, mean data should be readable manner, not any duplication. Yeah. Or parallelized task. Mean task could be task should be run in parallelly to just mean in datacom is massive volume. So if task run is sequentially, that will take a lot of time to dump data into data warehouse. So task must be run in the parallelized parallel form. Uh, there are a lot of ETL tool option. We have just like Airflow, Luigi, Pentao, Cover ETL, but we use Airflow in. And why we use Airflow? Because Airflow provides a workflow which is where Airflow provides the workflow which run through the some scheduler, and scheduler configuration is so easy. One of the tasks. Another is our DAG scheduler. We can say scheduler as a DAG in Airflow term. So a DAG is consists of the multiple tasks, and multiple tasks we assign in a workflow manner. So if downstream or upstream, so this we can easily design the task in upstream and downstream and dependency of the task. So this is so much configurable in Airflow. And Airflow also provide a programmatic way to design the DAG. Like in some of the tools, they are providing the GUI, like Pentaho. Pentaho, there is a GUI for maintaining all the flow, like transform and load. And if there is also some supports from the Pentaho, like we can integrate a custom implementation for extracting data in Java or JavaScript. So that is support is there, but this is not that much easy like in Airflow, where we can write a whole code in the Python, and we can manage the workflow very. And again, logging is one of the main concern for the ETL tool. How much data is fetched from the source and which DAG is not working. So in Airflow, logging system is very good. It's give a very descriptive manner information. It just show the information in very descriptive manner. So like in Pentaho and other tool, I personally I seen that log are not so much informatic. And yeah, this is the one of the cause. And there's also X, XCOM. These are the some features variable which Airflow DAG is giving for sharing the values from the different workflow. And again, Airflow ETL tool have the uh, a rich operators for all the databases, like transferring the data from one database to another database. And supports, again, it is also supporting that we can write our custom operators which fetch data from the source and dump into data warehouse. So again, dependency management, this is also regarding the workflow dependency managements. So there is some requirement in the ETL process, like let's assume task 1 is complete, then task 2 will start. And this is depend on the time scheduling. Let's assume that for 11. Okay. Let's assume that we can run a task at the 11 p.m. of the night, and again another task run on the mid of the day. So this thing can, if we can do this thing easily in the Airflow. So Airflow is the platform programming to article. So this thing already is here with work with these schedulers. And this is this some comparison between the Airflow and Pentaho. So Airflow main comparison is that Airflow is open source and free to use. Pentaho, we have to pay for the Pentaho web version. Community version is free. Yeah, our pipeline task is creating views, creating reports, creating UIs, access control, and auditing.
Great. Thank you, Mukesh. If it's okay, I want to hold questions until and discussion maybe to the end, so that we make sure that we have enough time for other people to get their presentations in.
Yeah. Okay, thanks.
Okay, great. And then I see there are a couple questions. I think Daniel asked about timekeeping. It'd be great if there is another timekeeper. I think Anthony and Nikki and Nikki and Ella Alan are doing our tag teaming. So if you can do your tag teaming and maybe keep it to 5 minutes. So maybe I'll let Nikki, can you go next? We'll go Nikki, Alan, Bashir. And then if somebody wants to go next, just put your name in the chat.
Oh, hi
And
everyone.
I would just suggest that people, if you have questions along the way, is just put them in the notes.
Hello?
Hi.
Yes, so can you see my screen? Hi.
Yes.
Okay, so I'll just present briefly what we are currently using in at AMPAT in production. So the need to do ETL has been there for some time. Before 2015, we were basically exporting data from OpenMRS to SAS and basically using SAS to do routine reports. And during that time, the data had accumulated, and you can see the statistics right there. So just to go over some requirements that we usually face, we are required to produce routine reports. I'm sure that's true for everyone. Sometimes we're also required to produce this one-off aggregate reports just to answer specific questions. And then we're also required to visualize our data. But what's important for at least our use cases has been the requirement to produce patient lists for the aggregate indicators that we produce. Yeah, so we in 2015 we started to use this flattening of ETL, I mean OpenMRS tables, and how we are setting that up. We are using two instances. So the primary instance is where the OpenMRS is running, and this basically represents MySQL database. And then we are replicating that to another node instance, and then running the denormalization queries, just plain MySQL queries to flatten the OpenMRS tables. And we do that incrementally every 5 minutes, and some of them we do it nightly. So it's a multi-stage process, meaning one flattened table will act as a source for another analyzed set downstream. So later on, we sync that to Elasticsearch, which we use for visualization, primarily visualizations. So that's currently how it looks. The client layer, serving layer, database layer, and of course the ETL transformation layer. So our approach for flattening is somewhat different from what I've seen in other OpenMRS implementations, whereby we in the base stages we are representing data as string. So you can see right here there's a concatenation of obs concept and obs answer. So you can see right here we're using screen representation there. So this one row here represents an encounter, and then how we analyze that in later stages is we're using regex expression. So this is a sample indicator, a sample analysis to just know what the enrollment date was for a patient, and you can see how complex it looks. So this just shows the the second stage table, at least for HIV analysis, and the analysis goes on. Apart from, so we are using Airflow. I think we've heard about it a bit from the previous presentation, and this allows us to basically to schedule and manage these queries. So basically, the challenges with our current approach has been number one, it's unforgiving, and the experience of coming up with these queries and actually doing the deployment is unfriendly. So we've had queries run for up to 12 hours, and sometimes they fail. So that means you can easily lose what you've done overnight. And then MySQL query execution and planning. So MySQL doesn't know how to parallelize queries, and so we have to help it by splitting our jobs into smaller batches that we can run in parallel, and that's how we are achieving some performance there. And then, of course, we had to really understand in terms of optimizing it for performance. So right now it takes about 7 hours to produce the HIV data set for that's rebuilding for about 9 million encounters and to 90 million orbs, and that's on a 64 GB 24 core machine. Yeah, so maintenance is painful because every time you need to redefine several indicators that affect each other, then you need to actually rebuild. Yeah, and we've started to run out of that window that we do incremental updates because the more jobs we add to that window, then it takes a long time for the amount of time it takes for the incremental job to complete starts to increase. And then, of course, we would like to use our resources that are on premise, server resources at night to speed up this analysis, and at the moment we can't. So I'm going to let Alan take over from here.
Right, Alan?
Hello, can you hear me?
Yeah.
Oh, sorry, I think I forgot to unmute. So I'm going to share my screen. I hope you can see my screen right now. Are you able to see my screen?
Not yet.
Let me see. Sorry about that delay. How about now?
No, I don't think so.
Yeah, let me share.
There we go.
Nice. Sorry about that delay. It was asking for some security problem. So I just wanted Nikki to present so that we can get the context why this is important. I know most of you already do. So after we experienced that challenge at Ampath, we decided to start coming up with designs. So we partnered with Antara Health. They're based in Nairobi. And we were just trying to see what might work and maybe come up with a prototype or proof of concept. So today I'll basically present some of the things we've done and some of the things we've learned from the community, interact with Bashir, Dimitri, and everyone who has been participating within the talk. So this was the initial design we came up with, and we came up with a prototype. So it entails having two pipelines. We followed an architecture called Lambda architecture, where you have a streaming pipeline and a batch pipeline. So the batch pipeline will be used on day 0, and whenever you want to rebuild the entire data set. And we're using a bunch of technology here, including Spark. PySpark really worked for us when we are doing when we want to parallelize some of the transformation. Another thing that we used was Kafka and Debezium, just to get the incremental updates to capture that change in the core OpenMRS. So if any changes happen within the OpenMRS, it will stream down to the Debezium, and then we subscribe to that Kafka topic that Debezium published in that within the Kafka cluster. And after that is when we now invoke a bunch of queries to do feature enrichment, not feature enrichment rather, but basically enrichment, including some of the data related to encounter that might have changed or orbs. And then now we dump it to we upsert it to the Delta Lake. So at the moment, it supports 2 versions of intermediate storage. One is Cassandra and Delta. So we chose these 2 because Delta, first of all, is a file-based. You don't need to install any software. You need only to have something like Spark, your analytical engine, which interacts with that Delta Lake. And it's made of Parquet file that have been, so Delta is an open source technology that has been modified to support atomicity on the Parquet file, so you can do batch and incremental updates on that. The main part where I wanted to highlight was it has the ability to do vertical and horizontal scalability. It can scale up or down, and it runs workloads faster. That's basically what Apache is for. And you'll realize during batch, when it's loading for the first time, it will send this. The thing that I liked about Spark MySQL connector, it sends about depending with the core you have, about if you have like 24 cores, it will send 64 parallel connection to the database. So something that will take 2 hours to fetch, it will basically take like approximately 16 to 30 minutes. So I'll go to next because of time. I don't want to spend much time on that. So later on during the community, we came across something called Apache Camel, which was suggested by Dimitri and Rafal, and I think quickly. So the previous slide, you'll notice that this is an overkill. Why do you need Kafka for a small implementation? This might not work when you have resource you don't have the enough server spec. So this is something we've been thinking and talking about in the talk. Why not introduce a change data capture that doesn't need Kafka, doesn't need Zookeeper? It's very light on the CPU in order to capture that change. So Camel basically will do that for us, but we haven't tested this. This is just a design that we are thinking of. And for those sites that will have small, or let's say less than 500 encounters, you basically don't need the batch pipeline. So we employ something like, it's called Kappa architecture, and you just remove the batch pipeline and you'll have streaming, and you can basically replay from day 0 to the current offset. So I think this will work for sites which doesn't need, which don't have a lot of server resources, or they don't have enough big data, basically. So we ran some simulation on that architecture, and I'll just briefly go through it, and so that because of time. So we virtualized it using VirtualBox and try to assess whether the Lambda architecture will work for different implementation. For 4-core and 4 GB RAM did not perform very well. In fact, the latency on streaming was very unstable, greater than 1 minute on average. But after 8 cores, 8 GB and above, it performed well with less than 17 seconds in latency for streaming, and batch took 1 hour for 100 million records. That is on the observation. That was about approximately, I think it was approximately 1 million encounters and 100 records per encounter. So we did that simulation on a VirtualBox using this specification. So one thing we realized that streaming wasn't taking much long, independent of the kind of server that we were using, and this was primarily due to a limiting of resources on each container. The entire stack is is containerized with 6 containers. So if you limit resources for each in each container, you'll find that it works. So let me just brush over it and go to the next. I'll skip this slide. So one key important thing that along this journey we realized was important was the representation of the output data frame from the extract part of ELT or ETL. You can extract a data frame that is very difficult to analyze, and it will cost you massive resources. So the way you represent it will really matter on how you'll analyze it. So this is the form we took. It's like a 3-dimension where you have basic information like encounter ID, location ID, visit ID, and also visit type, which is important for analysis. And then you have a semi-structured OBS data frame, which is nested for each encounter, which contains those properties like OBS ID, voided, and value type. The same structure used in OpenMRS. This is very standard, and you'll find that most versions of OpenMRS still use these fields. And it's very friendly to analytics. You just, for example, if you want to extract, let's say, weight, you just say write case when obs.concept ID is equals to that, else, and weight. You can basically write SQL or Python or whichever scripting language you need. So we tested this in production on a 30 GB RAM and 8-core test server. And we realized at some point there was some spike due to input rate, but on average there was during peak it was about 1.443 records per second, and we assess it to be performant. We haven't tested the batch layer to give exact statistics, but for small data set works well, but for large data set we need to test that. So just to finish, what are the lessons we learned in this endeavor? So we spent more time designing and testing. And then another thing, choosing of your tooling is very critical. There are 1,000 tools to use, so we will need to do a lot of research and design. And we also need to focus more on making the output data frame easy to analyze, because that is the output of this process. And lastly, we'll need to consider doing DevOps on the Docker container, since that will determine whether this stack will run on specific machines. So with that, I'll take this back to Jennifer. Thanks.
Thank you, Alan. It's great to finally see this all in one place in a presentation. We have about 15 more minutes left, so I think we have time for 2, maybe 3 more presentations. I think I said we had Bashir going next. Bashir, are you still
yes, I'm
ready
trying
and
to
willing
share.
present?
Yeah, I'm trying to share my screen. It lets me. Application. Okay, hopefully you can see my screen.
Yep.
Yeah, and I also I would be appreciative if people can share their presentations. It was actually great hearing from everyone. So mine is actually here. I'll try to be as quick as I can. Hopefully, I don't know, 6-7 minutes. But and I should say emphasize that. Well, first of all, I'm a software engineer in Google in the healthcare team in Google Cloud. And Dario with me, our product manager, is also on the call. So I am new to the OpenMRS community by all measures. So I think I joined in February. So please bear with me. Some of the questions and ideas that I have put in here might be premature. But I have been working on data analytics and ML systems for at least like 8 years in Google. So here are some of the observations that I have made and some ideas and questions mostly, which are actually, or some of them are actually covered in previous presentations. So I just skipped this one. I guess everybody knows what analytics, why we need analytics support separate from OpenMRS core itself. So what we are talking about here is basically like, on the left side, we have OpenMRS and MySQL that, basically it's working. It's out of a scope of the discussion here. And then, like Alan was talking about, like 2 paths for uploading data. One is the bulk updater or a batch pipeline, and the other one is the streaming part or a continuous updater. And then at the end of the day, we have a analytics data warehouse. Again, this part, the red arrows, again, out of scope for this discussion. From that analytics data warehouse, we may go to different presentations and UIs and reports and stuff like that. One other thing that I guess Bork mentioned on the talk, and it's important, is that, we can actually easily use the data in the warehouse in OpenMRS again, if you want to expose it in UI, for example. So the first question, and I would say the most important, if there is one thing that I would like to be discussed in the QA part, is this question: is what format do we want for the internal or the first data warehouse stage from which we create reports and other UIs? So we can. So one idea is just to replicate what is in OpenMRS, maybe with some flattening and denormalization. The benefit of this is that developers who know already OpenMRS can easily work with that. But I have been trying to suggest and that's actually where I started to discuss these ideas in our Fire squad, that I am proposing that we pick something else that is decoupled from OpenMRS internal data model for different reasons. And I'm proposing Fire here because I know Fire more, but there might be other ideas. So if someone else, the data scientists who work on the data warehouse, or maybe those who actually want to build like UI or dashboards on top of the warehouse, they don't necessarily know OpenMRS, and Fire is well documented. And the other thing is that if you have, let's say, some reports that are already based on Fires, or maybe at the at some point, if you want to actually integrate ML models that are already based on Fire, then it would be much easier to do the integration if we do the intermediate step in Fire. And the other benefit is that there are standards around the streaming and developing standards for the bulk data extraction for Fire, and those might be useful in other contexts as well. And then the third option is that, we come with something else completely different, like a star schema that was mentioned. So again, I just emphasize this is the most important question that I want to be discussed at some point, maybe not in this meeting, but later on. The other thing that, I'm suggesting is that, for the intermediate data warehouse, I think it's very important that, we can support SQL. It's a low barrier of entry for people who already know SQL, people who use OpenMRS, like developers. And then, the thing is that, as we heard from Nikki, and we had a discussion last week with Nikki and Alan, for many of the analytics reports, it's not just a number that we need. It also, like, if it's a number of patients with certain conditions, then we want to be able to drill down to the actual, individual patients. So we do need some sort of record level representation in the warehouse. And finally, for the format and schema, I'm actually questioning whether any flattening or denormalization is needed. And to just articulate this point really quick, like Nikki was presenting the denormalized table that they had, and there were, like, observations, for example, as a string in one column for each encounter. So another way to look into it is that, we can have like a repeated field for the observation in a single encounter. So still we have one row, and we still have the structure of the observations, but it's like a repeated field. Obviously, I'm not talking about MySQL. I'm talking about a warehouse that actually can support repeated fields. And sorry, actually, this is the other point. So again, I'm suggesting that, whatever we pick, it's kind of cloud friendly in the sense that, we can actually run it on a single machine and on-prem. But also, if we want to have the warehouse being hosted on cloud with many nodes running our queries, then it's should be very easy. I think I won't be able to cover most of the things that I have here. So I think the schema part that I covered is good enough. I just fly through this really quick in like 2 minutes, and I apologize for going through this too quick. So one key point was one key point was that, so actually let's cover this batch part. What I think is important that, whatever we implement, we can run on a single machine with multiple core, but it also can be horizontally scaled on many nodes. And as it was covered, I think it should be done on a replicated MySQL database, and maybe multiple replication if the amount of data is actually huge, and also we have constraints on how fast we want the batch pipeline to be. What I'm suggesting here is to implement this with Apache Beam. The reason is that, you kind of separate this from the underlying runner. It can, you can run the same code on a single machine with multiple cores. You can run it on Spark, on Dataflow, on Flink, or whatever. This is a sample case that, I did from OpenMRS to BigQuery. This is sample, queries that, I am showcasing how this can be done on Fire and BigQuery. Let me just skip these. And for the streaming part, I just finished with this point. I have a few more slides. You can look at those, but I think this is the key point for the streaming part that maybe we need to discuss more, is that if we want to actually do this for a single OpenMRS, MySQL instance, or we want to actually integrate multiple instances together. Like, I think the first presentation that Mukesh was talking about multiple instances, but on talk, we actually kind of agreed that we are separating the sync problem from the data warehouse and analytics problem. And if we are making this assumption that it's a single machine, then I think the architecture can be much simpler, because if the amount of processing that we do for a single event is proportional to what OpenMRS does for that update event, then we don't need any kind of cluster or multiple nodes to do streaming. It can be done on the single node. So yeah, like I said, there are a few other proposals and options. I think it's better if I stop now, such that we can fit in another presentation. Yeah.
Great. Thanks, Bashir. We do have about 5 minutes, so I'm not sure if people would like to have one more presentation, or as we have, like, I think about 3 or 4 people who may have updates to share. Our alternative is to set up a second follow-up time where we could have the remaining people present, and then we can start diving into discussing a lot of what we've heard.
Yeah, if there's one message that I've gotten here, it's that there's a lot of really great thought and work going on in this space. There's obviously a lot of interest, and we need a way to continue this conversation. So I think if we can find a way of sharing some of what we've got thus far in online, and have maybe some asynchronous discussion as we set up another time to continue the stand up, and maybe with some prep, folks will understand, like, we've got a lot of folks to talk, and we can try to be a little more organized.
Yeah, I was half wondering, why didn't we make this half an hour and a half? And yet I think we could have made it an hour and a half, and that still would not necessarily have been enough time to talk about everything we want to talk about. So maybe let's continue some of the discussions on Talk, ask questions in the chat, and we can port it over to Talk. And then I'll work on setting up another time for a follow-up stand-up and deeper discussion. Any last comments or questions from anybody?
I would just say we have the notes page that's been linked a couple times in the chat. As people have just gotten a taste of some of the great work going on, if there's questions you have about what was presented thus far, please make sure to add that to the notes page. The chat we may lose, but the notes will be preserved, and we'll have them for our next meetup. And then we'll plan on through Talk reaching out, and Jen will probably be reaching out to people individually to make sure that folks are prepared for next time, and we'll try to be efficient asynchronously as well.
I think one last question, Burke, before we finish.
Yeah.
I mean, I think it sounds like people are actively working on a lot of this stuff, and I know there's a couple of organizations that are investing in some of these technologies already. I'm keen to make sure that we're plugging in. I didn't have a chance to present. We've done, but all the things that I saw are exactly in line with what we've tried to do, and covering the same sort of problems, just with better architectures and better performing solutions. So I'm really keen to start trying to leverage that, or to collaborate on something. So, I mean, is there a squad, or is there some sort of a way that we are going to, I guess, start gelling together some of these ideas into something that's going to be pushed forward, or what are the next steps?
Great question. So the intent of this is to start a conversation that will lead us to an ETL/ELT squad. And so maybe, Jen, one next step would be to make a Slack channel for this group, but also continue the conversation on Talk. But yes, Mike, that's exact intent, is to get folks with interest in this and working in this space working together.
So I'll send out another doodle poll to find out the next time. I think that conversation we can, Mike, I think we'd love to hear from you and Anthony if possible, and others who didn't get a chance to share. And then I think, if the first half of that next conversation is around sharing, maybe the latter half we can start talking about, well, how do we start moving towards something and working together to collaborate on something, forming this squad. And then I'll follow up on the Slack channel. I think there's already a Slack channel in place, but I just want to make sure that people who are there are here, and that we're not creating something different or duplicative.
Sounds great to me.
Yep. And I think the OCL squad, I think, is going to use this space, so we probably need to abandon ship and let them.
They have their Zoom room.
They have a Zoom room. Okay.
Yep, they have a Zoom room,
okay.
So we're fine.
Good. Okay.
But I know that people usually have something at the top of the hour to go to too.
Yeah. So thanks everybody for joining. Obviously, this is just the beginning of the conversation, but we want to leverage this momentum. So we'll try to keep the conversation going and set up a follow-up to allow a little more space. Thanks everybody for their contributions, and sorry for those that didn't get to contribute. We'll see you in cyberspace, and we'll have another call very soon.